Active noise cancellation is a fascinating feature of high-end headphones that requires some rather complicated engineering. Headphones such as these are able to eliminate or destroy unwanted noise that's produced by the external environment, while simultaneously playing the desired music or audio that's sent from your smartphone. In a nutshell, these types of headphones do this by using a microphone to measure the unwanted noise produced by the environment, and then calculating an anti-sound wave. This anti-sound wave is added to the waveform of your music or audio, and when the combined waveform is played through the headphone speaker, the external noise is eliminated or cancelled out, and just the desired audio remains. That's the basic principle. But there's a lot of intricate engineering that underpins active noise cancellation. In order to better understand the engineering, it's easier to visualize sound waves not as these sinusoidal patterns, but rather as a set of traveling high-pressure zones, known as compressions, and low-pressure zones, known as rarefactions. Let's say you live or work next to a highway. All the cars and trucks that zoom by generate a sound with a waveform such as this, which is really just a sequence of traveling high-pressure and low-pressure zones. These compressions and rarefactions move through the air, and when they hit your eardrum, you hear the sounds of the highway. In order to produce an anti-sound wave for the highway's noise, a sound wave must be generated that's equal and opposite. By that, we mean that for every high-pressure zone from the noise, a low-pressure zone needs to be generated, and for every low-pressure zone from the noise, a high-pressure zone needs to be generated. The noise and anti-noise meet, and when these low-pressure zones and high-pressure zones meet, or vice versa, they average out in that area, thereby eliminating the sounds from the highway. There are a few engineering challenges with this solution. First, the headphones or earbuds themselves provide some passive noise insulation, and therefore we need two microphones. One microphone is used on the outside to measure the noise itself, and the second microphone is used on the inside of the headphones to measure the percentage of noise that's getting through the sound insulating properties of the headphones and into your ear. The second challenge is that it's rather difficult to perfectly time the anti-sound wave with the external noise. The noise from the highway has hundreds of compressions and rarefactions every single second. So, if the anti-sound wave is off by a few milliseconds, then the noise cancellation won't work properly. Therefore, a high-powered digital processor is used to measure and calculate the perfect anti-sound wave, while simultaneously the interior microphone is monitoring whether the active noise cancellation is in fact working properly. Note that active noise cancellation is more effective for low-frequency, repetitive noises because they have only a couple hundred peaks and troughs, or wavelengths, every second. But high-frequency noises have thousands of wavelengths per second. If there's even the smallest inaccuracy in timing the anti-sound wave with the high-frequency noise, the resulting combination between the anti-sound wave and the high-frequency noise will be ineffective. The third challenge, managed by the processor and circuitry, is that the anti-sound waveform needs to be combined with the audio waveform that's sent from your smartphone. The audio plus the anti-sound acts just like different instruments in a song, and they combine to make a new sound which is played through the single speaker. When the combined audio plus anti-sound waveform and the noise from the environment mix, the anti-sound component of the combined waveform and the noise from the environment cancel out, and we're left hearing just the desired audio. We made a separate episode that goes over the different components of these headphones, and we're working on future episodes that will cover other feats of engineering such as Bluetooth communication, the antenna, and the microelectrical mechanical system microphones. This video was made possible by our sponsor, PCBWay. PCBWay can quickly manufacture your PCBs with competitive prices, impeccable standards, and They also provide PCB assembly services, where they populate and solder the components to the PCB. Check them out using the link in the description below. Also, one quick note about the 3D model. These are the Apple AirPods 2, which don't actually have an active noise cancellation feature. In order to model the interior of these headphones, we have to get detailed pictures of each component, which, as you see, can be rather destructive. We have exterior models of these other rather expensive headphones, which do provide active noise cancellation, but no interior models of them. Sorry for the switch up, which we hope wasn't too confusing. Furthermore, check out the creator's comments in the English Canada subtitles, where we discuss the difficulties of implementing noise cancellation in a room. We'd also like to thank all of our YouTube and Patreon sponsors for helping us build these in-depth engineering explanations. You can also provide your support by subscribing, liking this video, and commenting below. This is Branch Education. Thanks for watching.